In this podcast, we're going to look at the statistics final review notes, so things that you should know for your final from the first chapter that we did this semester. So first we started with some review. We have mean, median, and mode. So to review, mean is the mathematical term for average. So let's write that up. To find the average, you just add up how many terms you have and divide by how many there are. So mean is the average. Let's make this thicker here. So mean is the average. We'll take a look at in our calculator what that looks like. So you might see it written like this. X bar is the average. Median is the middle term. If there's two numbers in the middle, you can add them up and divide by how many there are. Mode is the thing that's the most common. You can have one mode, you can have more than one mode, and sometimes there's no mode. So let's find all three for the following numbers. So without any technology, you could put these in order. So if you put them in order, we have a 1, 2 4s, a 5, 6, 8, 9, and 10. All right, so those are our numbers in order. To find the average, again, you add them all up and divide by how many there are. I just want to review how you find the median, the middle. You could cross off numbers from each end until you get into the middle. So we could cross off the 1, the 10, the 4, the 9, the 4, the 8. If there's two numbers in the middle, you average them. So 5 plus 6 is 11. Divide by 2, you get 5.5. Or some of you already know that the middle number there is 5.5. And then here the mode is 4 because it happens twice, where all the other numbers happen just once. All right, next we looked at standard deviation. The definition of standard deviation, it's the average distance of each term from the average. So standard deviation is let's try that again, the average distance from the average. And so if we look at our numbers, they're pretty close together. So if you were estimating right here, the standard deviation is going to be pretty small because these numbers aren't spread out very far. So to find the standard deviation, we can do this on the calculator. So I'll show you how to put that in. So on your calculator, you can do a new document, open a list and spreadsheet, and we're just going to type the numbers in. And I'll call my list X. You have to name your list. So I'll put them in the order that they are on our paper, so you do not need to put them in order. So we have 4, 9, 6, 8, 4, 1, 5, and 10. You can just leave it right there. Yep. You too. You can just leave it right there. Okay. Oh, you're looking for your folder? So then after we type those in, make sure you're on a cell that's not in your list, and we're going to go to Menu, Statistics, Stat Calculations, and we're looking for one variable statistics. One list, we can arrow over and select our list here, and then when you hit Enter, it has a bunch of numbers here, and here's standard deviation, so it's the symbol right here, 2.8, and what that means is on average our numbers are 2.8 away from the average. So again, it's a pretty small standard deviation. If your standard deviation was 0, it would mean that all of your numbers are the same. So let's write that down. The standard deviation symbol looks like this. And for this problem, it was 2.8. Okay, so again, if your standard deviation was 0, all of your numbers would be the same because they're 0 away from the average. All right, let's use those numbers to create a box and whisker plot. All right, so we know the minimum number is 1. The maximum is 10. We can find Q1, Q2, Q3. We can do that by hand or in the calculator, so I'll show you both methods. By hand, again, you have to put all the numbers in order. So we have 1, 4, 4, 5, 6, 8, and 9. Oh, 8, 9, and 10. Okay, so if the number's in order, to find Q2, Q2 is another term for the median. You cross off until you get to the middle. We knew that was 5.5. Oops, let's move that down. So that was 5.5. To find Q1, we take a look at the first half of numbers, so everything below the median, and we look for the middle. So here if we cross off, the middle is between 4 and 4, so Q1 is going to be 4. To find Q3, again, we look at the second half of data, so everything above the median, and look for the middle. Here it's going to be between 8 and 9, and so if we average that, 8 plus 9 divided by 2 is 8.5, or you should know 8.5 is the middle. So that gives us Q1. The median was 5.5, and Q3 is 8.5. All right, let's use that and make a box and whiskers plot. So I will erase some of my work here. Okay, so to make a box and whisker plot, we know that the min is 1, the max is 10, so we should go at least from 1 to 10. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so to make a box and whiskers plot, I'm going to put dots at the min and the max. So at 1 a dot, at 10 a dot. I'll put lines for Q1, Q2, and Q3. So at 4 we draw a line, 5.5 we draw a line, and at 8.5 we draw a line. So we can see that this data is not spread out very far, and so there's your box and whisker. So if I ask you, does this data have any outliers, you probably would say no, but let's figure that out mathematically. You could just leave it right there, too, not stick it in your folder. All right, so our range right here is maximum number minus minimum number, so max minus min. In this case, it is 10 minus 1, or 9. So there's the range. The interquartile range is Q3 minus Q1. So in this case, it's 8.5 minus 4, which gives us 4.5. All right, we're going to use the interquartile range to find if there's any outliers mathematically. So the first step is to find the interquartile range, which is 4.5. So I'm going to write that down. First step is the interquartile range, which is 4.5. The second step, we take our interquartile range, whatever it is, and we always multiply it by 1.5. So in this case, it's 4.5 times 1.5. And if we do that, we get 6.75. Okay, so this is, I call our magic number. It's going to help us find the fences. So the third step, and I'm out of room here, so I'm going to move this down, and I'll show you how to find your fences down here. So right here, fences. Anything outside the fences are outliers. So to find the fences, it's always Q1 minus our magic number, 6.75, or Q3 plus our magic number, 6.75. All right, so in this case, Q1 was 4. We're going to do 4 minus 6.75. Q3 was 8.5, so we add our magic number. So if we have any number below negative 2.75 or above 15.25, anything outside of these fences will be outliers. So let's draw those in. So negative 2.75 is like about right here. Okay, so there's our first fence. And then we have 15 point something, 15.25, so our upper fence is like up here. And you can see that all of our things are inside the fences, so there's no outliers. So outliers are outside, any point outside the fences. All right. In Chapter 1, we also looked at percentile rank, so let's review the definition and how you solve. So let me get rid of some of this here. All right, in a class of 30 students, Hattie learns her grade of 95 out of 100. On the Chapter 5 test puts her in the 90th percentile. How many students scored lower than Hattie? So remember, the definition of percentile rank is what percent is below you. So let's write that up. Percentile rank is the percent below a certain point. We know there's 30 students and she's in the 90th percentile. So we want to figure out what is 90% of 30. So of in math means multiply 90% as a decimal is 0.9. And we do that, we get 27. So there's 27 students that did worse than Hattie. So she's in the top 3 students. So percentile rank, what percent is below you? We change it to a decimal and multiply by the total. All right, next we looked at normal distribution, this bell curve. And for sure, if I'm making a note sheet, this is something that I would add because I don't have these numbers memorized. So in this bell curve right here, if you're 1 standard deviation away from the mean, so the mean is the middle, then in this part right here we have, this is 30, I want to make this bigger, so hold on, okay, let's make this bigger. All right, so 1 standard deviation away is 68%, so if we divide it, this is 34% in this guy, 34% right here. So again, 1 standard deviation away right here, this is 68% of our data. You can see it from the graph, it's a lot. All right, if we go 2 standard deviations out, this guy is 13.5%. This is also 13.5%. And then it gets a lot smaller. This one, 3 standard deviations out, is 2%. And then out here is 0.5, 3 standard deviations away. So for sure I would put this on a note sheet. We're going to use that to calculate answers to the next problem. So let's take a look at that. Draw and label a graph for the following situation. The weights of 1,000 children were recorded on the first birthdays. The weights were normally distributed. Here's the average, and here's the standard deviation, 1.6. All right, so I'm going to draw my graph. And we draw a line down the middle. That is in a normal distribution, the middle is the average and the median. So this is 10.3. All right, then we got our numbers. We have 1 standard deviation away. We have 2 standard deviations away. We have 3. And what we're going to do is we know that the standard deviation is 1.6, so we add it above the mean. So this way we're going to add 1.6. And if we go this way, we're going to subtract 1.6. So let's do that. I think I did it correctly, so I'll write down these numbers. So we get 11.9, 13.5, 15.1. We subtract, we get 8.7, 7.1, and 5.5. All right, let's put in our percentages from what we did previously. So this is 34%, 34%. This is 13.5%, 2 standard deviations out. We got 2% in this column and 0.5% here. Okay, so if you take a look at that right there, that's 100% of our data. So let's calculate the next page. We're going to come back to this graph. So right here, what is the probability that a randomly selected child will weigh less than 10 kilograms? So I'm going to find 10 kilograms. It's about the middle. 10.3 is in the middle right here, so I'm going to say it's going to be a little bit less than half. So a little bit less than 50%, about 50%. But it'll be a little bit less than 50%, because we see the 10.3 is going to be a little bit less than that. What is the probability that a randomly selected student will weigh between 8.7 and 11.9 kilograms? All right, so if we take a look at that, that's 1 standard deviation away. If we add these together, that's 68% of our data. So we say, all right, 0.68%. And I think it was 1,000 children. Yep, so times, so of means times 1,000. Oh, I'm sorry, it asked probability, so I'm finding number of. So if it's just probability, you could just say 0.68 or 68%. All right, the next problem, though, does say how many. So if it's how many of the 1,000 children would you expect to weigh between, and let's change these numbers were typos, I forgot to change them. So I'm just going to pick one. How about between 7.1 and 8.7? Let's do that. So how many weigh between 7.1 and 8.7 kilograms? So if we take a look at that, that's this 13.5% right here. So I'm going to do, let's change colors, 0.135 of 1,000. So of means multiply. There's 1,000 children. So that would be 135 children are between 7.1 and 8.7, so that's 13.5%. The last one, how many of the 1,000 children would you expect to weigh more than 8.7 kilograms? All right, so how many again? So more than 8.7. So let's find the 8.7. That's this guy right here. So everything above this. So here's the first half. This is 50%. We're going to add the 34% to that. So add all those percentages together, and you get that's 84%. And 84% of 1,000 is 840. It's almost all the children. All right, so there's a brief review of our standard distribution, our bell curve. All right, let's look at types of studies. There's experimental, where you do the experiment. There's observational, where you observe the data, but they don't know they're being observed. And there's a survey, where you collect information. So on your final, you ask questions about this. Here are some examples. Arthur says that 71.43% of students hate the new school dress code. He interviewed 7 people in the parking lot after school and asked them, do you like the way the school's forcing us to dress? Number 1, identify the type of data collection used. that would be a survey because you are asking people the question. Number 2, explain how there might be bias or misrepresentation. Well, the wording. Do you like the way the school's forcing us to dress? Also, the number of people. There's only 7 people. If you interview only 7 people, it's not going to be a great survey, great data collection method. So there's some bias or misrepresentation. Okay, so there's chapter 1. There's several problems for you to go ahead and try, and then on Schoology the answer key is posted so that you can check your answer, and you can add anything to your note sheet for your final.